Behind me is the Unisphere. That's right, I'm in Flushing Meadows Park in Queens, New York. That is where Men in Black was shot, at least the segment where he fights the aliens. Actually, more historically significant, though, is the museum behind me, the Queens Museum. Between 1946 and 1950, that was actually the United Nations building where several countries were established during those years. Anyway, today we will be talking about project management. There are two schools of thought with project management, Agile and traditional. Agile I'm going to do another video on because it's just beyond the scope of what I can cover in one video. So today we're going to be talking about traditional project management, in particularly PMI PMP, which is Project Management Institute Project Management Professional. That is the certification in the United States to be a traditional project manager. I have that certification. It's a bloody hard exam to pass. 200 questions in 4 hours on covering 44 process groups and over 500 plus inputs. It's a hard exam. I'm going to cover all of the information that I think is most relevant in this video. You're going to get a brain dump right now, and I hope you appreciate it because you can take everything I spent my time studying and just learn it all in one video. At least that's my intent. Okay, now if you are from Europe, you may call this Prince 2. Prince 2 is the European equivalent to PMP. They're not that different. I've looked over the general ideologies of Prince 2. And if you come from a software background, there are other variations of project management formalities and ideologies like ITIL, ITIL, and SDLC, Software Development Lifecycle, and RAD, Rapid Application Development, blah, blah, blah. I'm going to give you the general overview of project management. This applies to any sector. It is most commonly used in two sectors, software development and construction, buildings or whatever it is, but it can be applied to literally anything that is a business, virtually anything, whether it be a service-based business, product-based business, whatever. Project management is always beneficial. Now, it is a complicated topic with a lot to cover, so I am going to hope that you can hear me over that wind. I hope that's not ruining the audio, and I'm going to go step by step. I may need notes. I usually do these videos from my head, but there's a lot to cover. So the very first thing you got to do when you create, well, you know what, let me backtrack. Why would you want to be a project manager? Hold on, I got to give you some incentive to keep going. I just forgot about that. Google what the average salary of a project manager is. It's a lot of money. Flat out, they make a ton of money, and they have a unique job where they're controlling the project as it flows, and it's a lot of fun. It's exciting. I like it. All right. Anyway, back to the first step in project management. Okay, first thing you got to do is create a project wiki for every project you do. If you don't know what wiki is, it's basically a bulletin board that anyone can modify and edit. But on that project wiki will contain the scope of work. What are you going to do in this project? So let's say your project is to create that giant structure behind me that was used in the World's Fair in, I think, 1939 and again in 1959, something like that. It was used twice. That structure was a restaurant up top with an elevator going up there. Pretty neat structure. Hasn't been used in many decades. Anyway, let's say that's your project. You're going to create that. Scope of work is going to be build out this crazy structure, figure out how to assemble it upwards, create the team that needs to be used. Oh my gosh, there's a helicopter flying right there, and that's noisy. I'm sorry about that. So your scope of work is going to be all the different things that you need to do to actually make that come to fruition. Let's say that was bare land there. You have to dig a structure, foundation structure, whatever it is. I'm not into construction. I don't really know what you're supposed to do for that stuff, so it's hypothetical, but this can be applied to anything. By the way, Flushing Meadows Park is right near LaGuardia Airport, so the constant flow of airplanes overhead is going to also ruin the audio. I apologize. Can't stop the airplane flow. All right, we're near an airport. Now, near a major airport, like the major airport in New York City. Okay, so now let's say you are going to have this scope of work. Now, what else is necessary to be on this project bulletin board, this project wiki? Besides scope of work, you also have to have who the project stakeholders are. along with their contact information. So let's say you have the owner of the property of land, you have the main person who's behind all the construction, who's leading the construction crew. You could have whoever, the person financing the project. All these people need to be listed out with their contact info that's available to everybody who's in the who's relevant to the project. Because if something happens, you need to be able to contact these people. In the case of a construction project, you probably want to also have whoever's involved with getting construction permits. So let's say someone wants to shut you down because you don't have the right permits, you have to be able to pick up a phone call and easily access that person. Okay, other things that need to be on that project, on the project bulletin board, Wiki. I'm going to use my notes, I need it already. Hang tight. Deliverables, that's a good one. Deliverables per milestone. What it is they're going to do at each milestone of this build. So let's just assume, I don't know how they built this, but let's assume they build the upper platforms first in some kind of concrete mold, built these center columns which house elevators as a second process, and then they had to somehow get those big things up there, and so they stay up there. All right, and then eventually install elevators into the actual concrete center structures. Let's say that's your scope of work, okay? Now, you have several iterations of that project. You have to first form the molds, build the molds to create those things, create the actual platforms up there, and then have some form of construction to get it up there and assemble it all into pieces. Those are your iterations. You have to know what it is expected at each of those iterations, what the deliverables are. So obviously, if your deliverable is a big platform like that, it's very concrete. That's an interesting pun, it's made out of concrete. But based on what your deliverables are, is going to dictate how long each of those iterations are going to go for and what the milestones are expected each. That kind of stuff has to be on your scope of work, which should be available to everybody on the project so there's no mystery. Now I'm going to go down to the next topic. Let's say you have a date of delivery and they say we want to have this built by, I don't know, next week. You know that's unrealistic, right? All right, well, they're going to say, well, what do you have to do to actually get it built? What do you need? What is the actual elements that you need? If you don't know those elements, you can't commit to those deadlines. Never commit to a deadline, never commit to a date without data. That's a good thing, all right? So anytime the scope of work includes a deadline, you want to make sure there's data so you know what it is you're doing in that scope of work. Okay, now let's talk about resource breakdown structure, RBS. It's the next thing you need to create for your project. And RBS is a document that contains all the resources available to you for this project. All right, now some of those resources could be human resources. This is my staff, this is my crew. Some of it could be physical resources. These are the construction equipment that I have available to me. These are the suppliers that will send me concrete structures as needed. I don't know what they do for building. All right. So basically all the resources, be it physical or human resources, need to be listed out in your resource breakdown structure, RBS. Next thing you have, work breakdown structure, WBS. WBS is kind of like the scope of work, but more detailed. Every single iteration of your project, what exactly do you have to do? What is the work that needs to get done? So in the case of molding those things, the work would be build a mold, get someone to pour the concrete into the mold, wait for it to settle, and then transport it to the location. I guess that would be an example. God, I don't like using construction examples because it's not an area that I'm so familiar with, but I'm hoping these are accurate, semi-accurate anyway. Okay, so now that's your work breakdown structure. Some people also include, and this is not a requirement, it's an option, a WPS Dictionary, work breakdown structure dictionary. What that is basically just more details on the same topics in the WPS. So let's say creating that concrete structure requires subtasks. Those subtasks can be defined in your WPS dictionary. So let's say you have to organize 24 people to get all the machinery or something. That would be more details than you'd put on the WPS. You create a work breakdown structure dictionary that contains more of those details. By the way, that was also part of the World's Fair. And it used to have an incredible map of New York State on the bottom, on the ground, made out of tile, but unfortunately the years wore it off. It was very beautiful at one point. Pretty cool structure. And that top part wasn't always just wires. There was actually a glass ceiling on that, and the glass shattered little by little over the 70 years since it's been in use, or 60 years, whatever it's been. Okay, so now let's go on from WBS. Okay, so every item on your work breakdown structure needs to have a cost-benefit analysis done to it. That's right, you got to figure out the ROI. You got to dollarize everything you do. Dollarize means figure out the dollar value both in cost and the value to the project for each item that you do. I'm going to try to show the inside of this. I don't know if the camera's going to pick it up in there. All right, not much to see in there. Yeah, it's cool. It was really cool, and these gates used to be open at one time, but now they're locked, and there's not much left to see in there. But anyway, back to project management. Okay, so each item in your work breakdown structure needs to have a cost-benefit analysis done to it. The reason you do that is once you have figured out what work needs to be done, maybe you don't actually benefit from doing it when you figure out the ROI. So let's say you're going to build a commercial structure that's 2 floors. How many staircases do you put in? Let's say on the work breakdown structure, you have scheduled to put in two staircases on the work breakdown structure, okay? To build them. Now at this point, you look at that and you go, what's the cost of building the second staircase? Obviously you need 1, but maybe you don't need 2. And figure out what the cost of building that second staircase is. Now figure out if you don't build it, how much money would you save? And what would you lose? So the most obvious thing you're going to lose is the second egress is required for fire code standards to increase the capacity, the person capacity on each floor. So if you have 1 staircase, you have a lower quantity of people who can be legally allowed to be in that facility on the second floor. If you increase that number, how much more can you rent the space for because you can hold more people? And that's a cost-benefit analysis. You build a second staircase, it has a cost of X dollars, and in response it increases the revenue potential by Y dollars. That's cost-benefit analysis, straight ROI. Alright, that's it. That's enough of work breakdown structure. Let's see the next item. Alright, scheduling. Let's talk about scheduling. You have all these tasks to build. You got to come up with a schedule of how this works out. What you have with every schedule is something called a critical path of dependencies. Your critical path of dependencies is your longest chain of subsequent dependencies. D can't be done before C, C can't be done before B is completed, and B can't be done before A is completed. That's your critical path. You need to figure out the critical path of any project in order to be able to ensure that you have your order of priorities set straight. And ideally, if you could figure out that things are not on the critical path, you can do what's called fast tracking them, meaning they are done in tandem. So 2 items that don't have to be done sequentially but can be done in tandem should be done in tandem. That's called fast tracking, when you identify items that are normally in sequence but actually can be done simultaneously. So for a random example, if you're going to build this skateboard park, you don't need to wait for the platform to be built to put the handrails in. Okay, those kind of things can be done in tandem. Now, as a different example, if we're going to go back to that structure over there, you're going to have to build the base before you're going to put the top on. That's your critical path. Obviously, you cannot lift up that thing in the sky and hold it there if there's no pole, if there's no center column structure to hold it. That will be a critical path of dependencies. So each of those aspects comes down to scheduling, and the more you fast track, the faster your project gets done, and typically that usually results in lower costs, and obviously happier customers if you build things quicker. All right, that's construction. That applies to every industry. Let's talk about risk management, okay? Risk is both positive and negative. Most people associate risk as only negative, but there's positive risk. Risk is anything you don't really anticipate to happen that may happen. Okay, risk could be your construction site, someone gets hurt. That's the typical assumption of risk. Someone gets hurt, and now how do you manage that? Or it could mean that unexpectedly someone granted extra funds to, let's say, a philanthropic project. All right, something nonprofit. Unexpectedly, you get an extra $1 million budget. Now, how are you going to use that budget to improve your project? So now, in your risk register that you create for this project, you have to also include contingency plans. What if this risk comes to fruition? What are you going to do? That's what a risk register is. And you try to think of all the possible scenarios that are likely. You don't have to have everyone under the sun, but only the likely ones are necessary. Change log. Oh my God. If you do not embrace change, you are not going to succeed as a project manager, because every project goes through incredible changes. I'm going to cut across this field. It's probably more interesting because the other direction is just endless forest. If you don't embrace change, you are not going to succeed as a project manager. However, projects by their nature don't want to change, because you set up all these things like your iterations and your deliverables and your schedule and all these things, and then every little thing that changes will modify that. Unfortunately, that's what comes with the territory of being a project manager. So now, how do you go about change? Let's say I'm going to go back to building this thing again. Let's say the original project was to build those 2 restaurants up top, and then the third one down there, if you look right over there, was an afterthought. Let's just theoretically say, I don't know if that's true, it's probably not, but let's just say that was an afterthought, and they said, you know what, we should put a third one much lower. I don't know why. Okay, now, how do you go about when your project stakeholder comes to you and says, oh, we got to add something to the project or change something to the project? What do? The first thing you don't do is say, okay, and start building it. Every change needs to go through a formalized procedure to be approved. If you have someone verbally tell you a change, never do it. It has to be at the very least, written down in some way that you could prove this person was a stakeholder and told me to do this. Because if you just change something, it can end up later on in the project, someone else says, why is this built? We only had the budget to do 2. Why is there a third disc flying in the air here? Whatever it is, okay? You want to make sure every change is documented in some manner or fashion. If it's a larger project, you want to have a more formalized change process established. So every change goes through some kind of approval procedure, any variation from the existing project plan. Okay, here's a topic I like a lot because most people don't really think much about this, and that is quality. In fact, your level of quality on any project is a absolute concrete thing. Most people assume you just want to get the best quality results as possible, but that's actually not reality. Reality is your scope of work dictates your quality level, believe it or not. So like when you say, I want the best quality, but then you start cost cutting, quality is going to suffer at some point in that chain. So let's say there's something called a triple constraint. A triple constraint means you have 3 aspects to every project: the scope of work that needs to get done, the budget, and the schedule. And if you take away from any one of those, you have to also adjust the other one of those, at least one of the other 2 of the 3. If you don't do that, quality suffers. That's the whole point. Quality is determined by a combination of your scope, schedule, and financial resources, your budget. Okay? If you pull on any one of those sides, you have to adjust one of the other sides. Otherwise, you start getting a reduced quality. Now, let me give it a real-world example. Production of the car Yugo back in the day in Zastava Motor Works, former Yugoslavia. Okay? Those cars were considered to be the world's worst vehicles in terms of quality. They were also dirt cheap, though. So people didn't necessarily not buy them because they were so inexpensive. People still wanted them. So now let's say you're the person in the factory building these Yugo cars, right? When you know that the vehicles have a typical lifespan of less than 100,000 miles, you probably don't care that much if you miss a screw or 2 putting it in the car. And that makes further quality go down, degrade. And then think of company morale. I mean, how proud can you be of making the world's cheapest, crappiest car with the shortest longevity? So that impacts company morale. However, in the grand scheme of things, they're selling a very inexpensive car that there was a demand for at that time. So just by having that business logic, the world's least expensive new car you can buy, there actually was a business logic to this. However, most people aim for higher quality. Quality is determined by your weakest point of quality in your entire production process. So if you're building a car, there's lots of different parts. The lowest common denominator of mission critical item is your quality level. So if you build a car and you put in all these high quality components, good brakes, good engine, good transmission, but then you get cheap with the steel you use in the structure, aluminum today, and the car rusts away in a few years. Well, aluminum doesn't rust, but steel, let's say if you use a steel structure that's too thin and it rusts away, well, your quality suffers because of one part of that entire assembly chain. The logic behind this theory of your quality is impacted by your lowest point of failure, your lowest quality of failure point, is called 6 Sigma. And basically what it means is you should have less than a certain number of failures at each point within the assembly line. So the person creating the radio has to have a certain maximum quantity of failures in every radio they produce, and the person creating the wheels, same story, and each person. And if everybody has a maximum failure rate, then the end resulting vehicle is going to have a very low resulting failure rate as well. And that's kind of the idea of quality, is based on 6 Sigma. 6 Sigma is a complicated topic. It's way beyond the scope of what we're going to do here. And there's also a mathematical equation that goes with it that is not going to fit in this video. Items made in China typically use this low-grade quality of merchandise that has its logic. Many people want to buy stuff that's made in China because it's inexpensive. Even if that means the quality is not so good, people are willing to accept that. That's okay. It's not always bad to have a low quality product if there's a demand for it. It's not necessarily a bad thing. It isn't necessarily good for company morale, for the people working there, and it isn't good for longevity of the item, and you probably don't usually get high quality, many high responses from people saying they love your product, but there's a demand for these kind of things. Okay. Lastly, let's say you have completed your project and now you want to know if your project is genuinely completed, meaning the people working on your project have completed it, but is it really complete? Does that mean that it's complete just because everyone working on your project says it's complete? So the next aspect of project management is to create a QA procedure, quality assurance procedure. That procedure determines whether a project is genuinely complete. It is something where you have a series of check boxes that say, yes, the project scope has been completed. Every item within the scope appears to have been built correctly or created correctly and completed correctly. It has been done to a minimum level of quality. You have to check the quality of work. Sometimes with computer programming in particular, you have something that appears to work, but it fails under various scenarios. That's a very common aspect of software programming. People build things and there's endless bugs that are plumb obvious as soon as you do a quality assurance testing, QA testing. So that's part of your QA procedure. And you also want to assess whether it was done within schedule. Now, not keeping the schedule doesn't mean it wasn't completed, but you want to log that it wasn't kept to schedule. That's an important aspect of the QA finalizing of any project. Now, the last aspect, let's say you complete that project, you finalize it. Hallelujah! The project's done. And the last thing you're going to do as part of your project manager's duties is to set up on the same wiki that you used before, a new page with lessons learned. Things that you have learned along the way about what to do better next time. If it's a construction project, maybe your lessons learned is don't use that supplier again, he sucked. You know, every project is different, but you want to make sure lessons learned are documented so that you can learn from the project and learn from the current project so future projects are benefiting. In my personal experience doing project management work, the sad reality is that is probably the most neglected aspect of project management. People rarely set up a lessons learned page, and when they do, people typically don't read it. It's sad, but it's still part of project management, so I am teaching it here. That was my entire brain dump of everything necessary in my personal opinion, not a fact, my personal opinion. That is everything necessary to be a good project manager that you need to know. Hope you learn from this. Hope you love it. Hope you push the like button. Hope you share it. Please do. And we're going to have another video on this channel. containing Agile project management, was a whole different school of thought. So stick around, keep watching. Thank you for watching, appreciate your time. I may have lost my voice. It's January and it's cold. And I've been breathing this air and belting out the audio, man. All right, stick with me. Look forward to seeing you in the next video. Thank you for watching.
Yeah!